Okay, so we're picking up where we left off with the last lesson. We're continuing Dalton's atomic theory. The next bullet is that atoms combine to form compounds. That is correct. You may have heard of a little something called H2O. I know you guys are really new at this. Do you know what element is represented by the letter H? Hydrogen. There's two hydrogens in water. How many oxygens are there when you hear H2O? One. The two is in reference to the letter that comes before it. So when you hear H2, that means two hydrogens. If you don't hear a number, the number is always one. H2O, that would be two hydrogens, one oxygen. So that would be three total atoms. A hydrogen atom combines with another hydrogen atom and an oxygen atom to make water. Okay. And then finally, in a chemical reaction, atoms are separated, combined, or rearranged, but they are not destroyed. That's the big one. They are not destroyed. As I told you all yesterday, there are atoms and there are elements of carbon, hydrogen, magnesium, iron, nickel, all that you walk on that was here when the dinosaurs were around. Matter is not created. Matter is not destroyed. It cycles. There is statistically a molecule of water in this big jug that passed through a Tyrannosaurus Rex's body. Let's pass through me. Okay. And finally, we have something called conservation of mass. Whenever atoms are going through a chemical reaction, that nothing is created, nothing is destroyed, nothing is divided. They just get rearranged. Atoms are not created, destroyed, or divided in a chemical reaction. Let's see if you guys can figure this out. Alex, if you have 4 quarter pounders with cheese after school today, tell me the weight of food that you ate. 1 pound. Quarter pound, quarter pound, quarter pound, quarter pound. Now, would there be no reason to assume that if he ate 4 quarter pounders with cheese, each one weighs 25% of a pound, and if he ate 4 of those, he has 1 pound? If I gave you 4 quarters, what do you now have? Is there any reason to assume that if I gave you 4 quarters that you would not have $1? No, this is the law of conservation of mass. If this phone weighs 1 pound and you were standing on the scale at Publix and you weighed 145, I hand you this phone, 1 pound. How much do you weigh now? It's very simple. There's no tricks here. That's just the laws of nature. The number of atoms before and after a reaction are the same. So I'm going to give you guys an example here, and I'm going to go back to water, okay? So check this out. These are going to be oxygen atoms. I'm going to make them blue. How many oxygen atoms do I have? Somebody's phone is buzzing off the charts right now. I can hear it from here. How many oxygen atoms did I just draw? 4. Easy enough, okay? Here are hydrogen atoms. How many hydrogen atoms did I just draw? 8 of them. And then we're going to have water. Molecules. Here's what I want you guys to see. I'm no doubt that many of you are visual learners, so I hope this little diagram helps. I have 4 oxygen atoms here before the chemical reaction. How many oxygen atoms do I have over here? That didn't change. I have 8 hydrogen atoms here before the reaction. How many do I have over here? 8. It doesn't change. They got rearranged. That's fine. If I asked all of you to stand up and find a random chair, there are 31 of you here before you all changed. There will be 31 of you after you find a new seat. That never changes. So when you're dealing with chemistry, here's the bottom line. I can't say it any simpler than this. You had the same amount at the end as you did at the beginning. If he is 145 pounds before standing on the scale, he will be 145 pounds when he's off the scale. Take care of him. This is known as the law of conservation of mass. Mass is not created, mass is not destroyed. Are there any questions on that? Yes, sir.
So why, if I ate 4 quarter pounders,
Yeah.
I wouldn't be 1 pound heavier though. I'd probably be like.
That's because you have something called metabolism, and matter and energy are interchangeable. Your body will turn that matter into actual energy. You know, when I put gasoline in my car, like I did this morning, I put maybe 8 gallons of gas in my car. My car right now has a full tank, or, you know, half a tank, but it uses that gasoline and burns it to produce energy, and then it comes out as exhaust.
So I'm saying, like,
When you put food in your body converts it into energy and heat, and you give off heat and you use energy to move your body. It's called metabolism. So you're giving off that energy, and that energy is actually powering your systems. It's powering your organs, your cells, your brain, your organ, all that stuff. But you give off a lot of it as heat, and you can't get that back. So that matter, that solid food, can be converted into heat, and you give off heat.
let's say if I ate 4 quarter pounders that day, I would be like 3 pounds.
No, you would be 1 pound. You'd be 1 pound. That's called secondary production. It's if you had a backpack, and I gave in that backpack, let's say it weighs 2 pounds by itself, I gave you 10 pounds worth of books, you know, I have 12 pounds on your back. I mean, that doesn't change, but it is a little bit different with biology, because we burn food. You know, if you eat a pound worth of burgers, you're not going to have 1 pound of poop, because a lot of that matter that you ate will be converted into energy for your body, and your body just gets rid of whatever it can't use, whatever's left. Okay. Let me turn off this lesson.